Hello, this is Ms. Bryant, and we're going to go over lesson 5, which is slopes don't have to be positive. All right, and our goal for today is to find out what a negative slope actually means. And we know that we understood today's lesson if we can look at a graph and tell if the slope is positive or negative and explain how we know, and to be able to give an example of a situation that would have a negative slope when graphed. So, our first activity is going to be a Desmos activity, which we will come back and do in our notebook, the notes from the activity. So as you can see here, there is a link to my class here on the PowerPoint that you guys have access to. So what we're going to do right now is we're going to click on the link, everybody that's in class, and we're going to start off the first part of our notes in the Desmos activity. And then we're going to come back here and continue on with our notes. So let's all pause the video here and go on and do the Desmos activity. All right, so hopefully after doing the Desmos activity, you have a better understanding of the 4 types of slopes and how to find them. So we're going to put in our notebook what we learned from the Desmos activity. There are 4 types of slopes. I'm just going to do a quick little coordinate grid to demonstrate the different types of slopes. The first type that we're going to look at is a positive slope. This is where the line looks like it's going up, like it's going up a hill. So some people might refer to it as uphill. The next type of slope we're going to look at is a negative slope. As you can see, it's the opposite. It looks like it's going downward or downhill. Our next type of slope is the slope of a line that is horizontal. And this is known as having a slope that is equal to 0. So if the slope is 0, you're just going to draw a horizontal line. And then our last type of slope that we're going to look at is a vertical slope. I'm sorry, let me write horizontal. And this is a vertical slope, and this is a slope or a vertical line, and this has a slope that is called undefined. And the slope is basically undefined because in finding the slope for this line, it causes you to divide by 0, and you can't divide by 0. Think of it as you have 5 iPads and you're trying to divide that amongst 0 friends. Well, if you have 0 friends, you can't divide the iPads. So, undefined slope. That's mainly why. All right, so how did we find slope from our activity? If you're not familiar with this terminology, then hopefully you will become familiar with it. To find slope, Remember, we use the letter M for slope. You do what's called rise over run. All right. And basically, rise over run. Rise is just referring to how many times you go up or down to get to the next point. And then run is looking at how many times you go left or right. So again, rise is your up and down movement, and run is your left and right movement. Okay, and so rise relates to, remember when we talked about the vertical distance, and run relates to the horizontal distance. So if you remember this little thing that we've been doing for a while, vertical over horizontal, that's what rise over run is referring to. They're all referring to the exact same things. Right? So if we look quickly here, we have two examples of different types of rises and different types of runs. So if we were to just quickly put that in our notebook, just quickly draw those lines. There's two ways you can find the rise or run of the line here. I'm going to use some color real quick, you guys. That way it's not too boring. Here's my run. Here's my rise. In this first example here, you're going down and over. So this is an example of a rise that goes down. And this is a negative movement. So for your rise, instead of going up, you're going down. And so that's negative movement. And then for your run, you're going to the left, which is also known to be a negative movement. And mainly because if you look at the coordinate plane, when you go down the y axis, the further down you get to the y-axis, the further you get, or the closer you get to the negative numbers. And then moving to the left, that's dealing with your x-axis. And if you move to the left of your x-axis, you're getting to the negative numbers. So that's why it's referred to as negative movement. So this is just one example of how you can find the slope of the same line. You can go down and to the left, or you can go up and to the right. And so obviously, if your rise is going up, that's a positive movement. And if it's going to the right, that is also known as a positive movement. So those are the ways that you can find, two different ways you can find the slope of the same line. I can go down and to the left, or I can go up and to the right. Either way, it's going to give me the same slope. All right. So for our next activity, we're doing the activity called Stand Clear of the Closing Door, Please. And so, I know that kind of sounds weird, stand clear of the closing door. There's no doors closing around here. But as you can see, it is referring to what the activity is actually talking about. So 5.2, our next activity, stand clear. As you can see here, it says that Chicago's public transportation use a Ventra card. Not all major cities use the same system. I know for New York, they have, I believe it's a Metro card. I actually went to New York for the first time in my life, and I still have my card. Kept it as a little souvenir. It's like a little paper thin thing. When we had that last major hurricane that put school out for months. I know y'all remember that, or at least 1 month. And so we can use what we've been doing today with slope and lines and graphing lines and writing equations for lines to help demonstrate real world situations and relationships to give us a better idea as to how to handle, like in this case, finances. So here we have Noah. He puts $40 on his card. So Noah has $40 on his card, on his Ventra card. And it tells me every time that he rides, it costs every time he rides, $2.50 is subtracted from what's on the card. So that tells me that every ride costs $2.50. Each ride. Let's use that. Okay, so what we want to do is we want to graph the relationship between the money on the card and the number of rides. So if we use our grid here, I'm going to zoom in just a little bit so that we can see this better, so we can actually graph our relationship here. So he starts off with $40 on the card. So not taking any rides or not riding the public transportation system, he still has the $40 on his card. Now, let's say he rides it 2 times. Well, it costs $2.50 for each ride, and that's coming off of how much he has. So his money isn't increasing here; it's decreasing because the situation said money is being subtracted every time he rides, and the rides cost $2.50. So 2 times $2.50. If I take that away from 40, which is $5, $40 minus $5 for 2 rides, he has $35 left. If he does 4 rides, well, I have to figure out how much the 4 rides cost, which 4 times $2.50 is $10. And then if I take that away from what he started off with, he now has $40 left on his card. Not 40, I'm sorry, $30 left on his card. And then if he does 6, that's taking more money off of his card, about 15. Take that away from 40. 6 rides, he will have $25 left. 8 rides, he will have 20 left. 10 rides, he'll have 15 left. And as you can see, you should start to see a pattern here. So 12, probably 10. 14, 5. And then 16, he will have nothing left. So I'm going to draw my line the best I can. So there is a graph showing him that Noah could use to help him to determine how many rides I can ride with this $40 on my card, or how many trips. I know in New York, we didn't just ride the metro once, we rode it multiple times. So if that's the case and how people like to travel in Chicago, Noah here would have to really consider, okay, where am I traveling to that day? I have 16 rides for $40. I really need to spread it out so I'm not spending a lot of money over time. I'm going to zoom back out. And so here, our next question is, why does it make sense to say that the slope of this graph is negative 2.5 rather than a positive 2.5? The slope being negative 2.5 makes sense And it makes sense mainly because that's how much is being taken away from his initial amount every time he rides the metro. If money was being added, then, I'm sorry, guys, if money was being added, then we would use a positive 2.5. But since money is being taken away from him every time he does something, that's why the number is negative. So that's why that makes sense. Because every time he rides, the money goes down by $2.50. If we let y represent the amount of money, it's the amount of money. I'm sorry, you guys. Okay, so y is the amount of money that he has on his card in in dollars. And x is the number of rides. What equation would represent this situation? Well, if we think back to how everything was graphed, the amount of money he had, what we did each time was we started with the 40, and every time he rode the metro, we took that, the number of rides, and we multiplied it by 2.5. And whatever we got, we took that and subtracted it from his initial amount. So the equation here that makes sense would be $40, what he started off with, minus how much it costs per ride. So that's the equation that makes sense in this situation. Now, you could write it another way, but this way, for most people, this is the other way you can write it, where the slope is first and then your constant is second. This way, for most people, makes more sense or helps them to understand the situation better. But either way would work in this case. It's basically what works best for you. When will there be no money left? Well, Noah will have no money after 16 rides. We determined that when we did our graph earlier. So after 16 rides, he will no longer be able to get on the metro or the metro, whatever they call it in Chicago, because he's already used up all of his money after 16 rides. All right, our next question is what point on the graph represents the 16 rides? The point on the graph that represents the 16 rides is this point here. You have to look on the x-axis. So this right here, this point represents the 16 rides. Right. So just like the point 040, 040 was our vertical intercept or our y-intercept, our starting place. The point 16, 0 is our horizontal intercept or our x-intercept. So before we leave for today's lesson, we're going to look at one more graph and see if we can interpret what it's telling us or what it means. So here's our graph. So what I'm going to do is I'm going to do just a quick sketch of what this looks like. What's it all about? This is talking about days past. This is talking about dollars on the card. This is point 20 where it's at. So I'm going to draw my line. This is what it looks like. Just doing a quick little span. This is from 1 all the way up to day 30. And our question is, what do you think the slope is and why? So my slope here, if I go back and look and review the 4 types of slopes that we looked at, I know that this is a horizontal line, and lines that are horizontal has a 0 slope. So the slope equals 0 because it's a horizontal line. So what would happen if we try to create a slope triangle on it? Well, let's see. So that's a good question. Can we create a slope triangle? Well, remember with slope triangles, we have to have rise over run. So I'm going to make some more pieces of my graph here. This is the very thing that I tell you guys not to do with your classwork, to use graph paper or the graph that we provide you on Canvas. And here I am, making a graph on line paper. But luckily, I'm not turning this in as work. It's just to prove a point. All right, let's see. Well, in order to make a slope triangle, my slope triangle needs 2 things. It needs a rise and it needs a run. So I got to see if I can do a rise and if I can do a run. So if I pick 2 points on my line here, let's say this point right here, 220. This point right here. Let's just say it's 620. If I pick these 2 points on my graph, all right, now I got to do my rise. Well, to get to this point from this point, do I need to go up or down? No, I don't. My rise is 0. I can't go up and down. I'm not going up or down anywhere. So my rise is 0. But can I run? Can I go to the left or right? I actually can. So if I start here, 1, 2, 3, 4, 5. I ran to the right 5 times. So if I was to try to calculate my slope, so if I was to do my slope, and that's rise over run, in this case, that's 0 over 5. The answer is not undefined, and I will show you that. If you look on your calculator and you do 0 divided by 5, you get 0. So my slope for this line is here, proven that it's 0. So can I create a slope triangle for a horizontal line? No, not for a horizontal line. So this should also help to even prove even further why this is a zero slope. All right, so hopefully after today's lesson we have a better understanding of what a negative slope is and what it means and can possibly mean in context of questions. Hopefully after the Desmos activity